Hello, scholars. I'm a little under the weather, so I have a feeling I'm probably going to sneeze at some point. I'm really excited to see how it sounds in a microphone, so I'll keep you in suspense, okay? Who knows, maybe it won't even happen. This reading is partially review from physics and even from previous this year, but still make sure to pay attention to it and follow along because it's really going to lay a foundation for this Unit 8. So what's this about? It's about heat flow and exo and endothermic processes. I remember exo, that's like exit, and endo, I remember that's like go in. Let's read the rest to remind myself. Alright, what does this say? Energy is the capacity for doing work or supplying heat. That sounds like a good definition. I should probably write that in my key points. Good idea. I know. So energy, capacity to do work or heat. Nice notes. Here, let's make it a color. Blue. Oh yeah. Unlike matter, energy has neither mass nor volume. Capacity to do work and no mass or volume. Man, I should read the whole paragraph before I keep taking notes, or I'll just rewrite the whole paragraph. Energy is detected only because of its effects. A hot water pot, right, that's a lot of energy. Speeding car, an explosion, all high energy. High energy. Thermochemistry, thermo, that sounds like temp. Whoa. Oops, sorry guys. So temperature is a study of how energy changes in a chemical reaction and changes in state. State, like Illinois, California. No, I think it's saying state like gas, solid, etc. Liquid. The energy stored in bonds is called the chemical potential energy. The energy for moving atoms is called kinetic energy. Potential key points. Oh, potential. That wasn't even on purpose. Key points or questions from those. You might want to pause it and write some down. What's this say? Heat, represented by Q, so Q is heat, is energy that transfers from one object to another because of a temperature difference. So heat equals energy transfer because of temp, so just T. One of the effects of adding heat to an object is an increase in its temperature. Usually. Heat always flows from a warm object to a cool object. I guess that makes sense. A cold object isn't going to give off heat to something. If I touch something cold, I don't get hotter. I get colder, right? I lose heat. I'm the warmer object. Makes sense. The molecules of the hot object move quickly, right? So high temperature, high random molecular motion, and bump into the molecules of the cool object, speeding the molecules in the cool object up. Heat is expressed in joules or calories. So joules with J, I know that one. Calories, that's new, but it's like calories in food. Both are units of energy. The joule is equal to the energy spent exerting 1 newton, oh I remember that from physics, N, of force through a distance of 1 meter. Seems random. The calorie is the amount of energy needed to raise 1 gram of water 1 degrees C. Seems a little less random. The calorie, capital C, on food packages is actually 1,000 calories. That's like a kilocalorie. Actually, I bet you they call it that. What's this diagram say? Okay, heat goes this way. Higher temperature object, higher average force of collisions. Particles slow down when they collide with particles of a lower temperature object. Decrease in energy. So these are going to lose energy. So decrease in energy. And these ones, lower temperature object, lower average force. Particles speed up when they collide with particles of a higher temperature object, and they increase in energy. So this one, the temperature goes up. This one, the temperature goes down because heat is flowing away. What else is in this reading? Oh, looks like one more paragraph. So sad. It's going to end so soon. Reactions either give or take energy when they react. This heat, Q, is called the heat of reaction or the enthalpy of reaction, delta H. Read delta H. Yeah, that's a delta, Greek letter delta. At constant pressure, the enthalpy of reaction is equal to the heat change as well. So Q equals delta H at constant pressure. If the heat of reaction, so constant pressure, HP. Why not? If the heat of reaction is negative, that means the system has lost energy. Okay, so delta H equals negative, system lost energy, exothermic. Okay, so lost energy, heat is a product, so negative heat product lost energy. This is all exothermic. So I guess endo is the opposite. Endo delta H equals, no, I should read it. If the heat of reaction is positive, that means the system gained energy. Heat's a reactant. Reaction is endothermic. Heat is entering the system. So delta H equals positive heat reactant gain energy. That's endothermic. What does this say? Surrounding system. So heat goes in. Delta H is greater than 0. It's endothermic. So heat equals reactant. Then here, system, heat's losing. It's exothermic, so heat is being produced. Heat equals product. Same thing here. Oh, they wrote it both ways. See those big old oars? It's like a rowboat. Okay. 2Ki goes to I2 plus 2K. Delta H is positive, and heat is a reactant. So that's endothermic. Exothermic, see how delta H is negative, and this is a product. Interesting. Make sure you have key points and questions. I will see you on Monday, Tuesday, and I'll have the rest of the videos and the rest of the packet done for then. Bye-bye now.